Welcome to lecture 37. In this lecture, we will solve a numerical on salient pole synchronous motor and we'll try to understand the concept about this. The basic thing that we need to understand is how to find EF. Now, this is a numerical in which it has been mentioned that it is a salient pole synchronous motor. It is connected to a 3.3 kV line. That means that the grid voltage is 3.3 kV line to line. So the line to neutral voltage or line to ground voltage will be 1 by root 3 times of this 1905 volt. It is supplying a 262.4 ampere at unity power factor. So the current is 262.4 ampere. It's a salient pole machine. So it has a direct axis reactance of 4.01 ohm and a quadrature axis reactance of 2.8 ohms. The question is, what is the EF here? In our last class, we have solved a numerical for a salient pole synchronous generator. This is a similar type of numerical, but here it is salient pole synchronous motor. Now, before we go to salient pole synchronous motor, let's quickly write what will happen in case of a motor and generator non-salient pole. For a non-salient pole synchronous generator, what we write, E is equal to V plus IA XS. How we write this? This is my machine. This is the synchronous reactance and it is connected to a grid. So if it is a generator, we assume that the power is flowing like this from the generator to the grid. So we give an arrow in the direction of power flow, and now if you write KVL, this voltage, since the direction of arrow is in this direction, this voltage equal to this plus this. This is my V of t, this is E of f, this is IA into XS. Since the arrow is in this direction, we write like this. What happens in case of a motor? In motor, the power flows from the grid to the machine. So we give a arrow in this direction. We give a arrow like this. That is, the power is flowing from the grid to the machine. Now, since the arrow is like this, if we write KVL here, it will be E of f, or I'll write like this, V of t will be equal to E of f plus IA XS. If you have to write an expression of EF here, EF will be equal to V minus IA XS. These are all vectors. This is one way of explaining this. There are different way of doing this, but in this class or in this lecture series we have taken this convention. So for a motor we will write EF is equal to VT minus IA XS. Now for a salient pole synchronous generator, in our last class we have seen that E of F is equal to V plus IA XS plus IAXQ plus ID into XD minus XQ. This we have seen in the last class. These are magnitudes. Now in this class we are talking about a motor. So this expression will be like this. We can derive it also, but due to paucity of time I am just writing the expression. For a generator these are plus, for a motor this will be minus. We have done almost a similar thing for a salient pole synchronous non-salient pole synchronous machine. For a generator this was plus, for a motor this is minus. In a non-salient pole machine there is only one term, in a salient pole machine there are two terms, one here, another here. Now let's see about this numerical. What we can write about this numerical? See, here we have to find E, V is given. So let's first find out IAXQ. Let's first find out EF dash. EF dash is nothing but V minus IAXQ. So what is the value of V? V is 1905 at an angle 0 minus IA. IA is 262.4 at an angle of 0 into XQ. XQ is 2.88 at an angle of 90 degree. Now if you evaluate this, it will come to be 2094, sorry, 2049 at an angle of minus 21.63. If you evaluate this, it will come like this. Now this one, what we have done, let's draw a phasor diagram. This is my, say, this is my V, and this is my I. So V, this is IAXQ, this is, we have come up to this V minus IAXQ is equal to this. Why IAXQ I have drawn like this? IAXQ is basically in this direction. This is the direction of IAXQ. Since there is a minus sign, we have drawn it in this direction, and now this is EF dash. Now this angle is 21.63 degree. This is nothing but the power angle delta. So what is psi? In our last class we have seen about psi. What is psi? Psi is delta minus phi. This we have to be careful about the magnitude, about the sign of this. Now psi we calculated as delta minus phi. What is the value of delta here? Since this is my reference V and E is below this, we will write this one as minus 21.63. Be careful about this minus sign. And phi is 0, so psi is minus 21.63. So next what we will do, we will find ID. What is ID? ID is nothing but IA sin psi. Okay, so what is the value of IA? IA is 262.4 into sine of minus 21.63 degrees. This comes to be minus 96.6 amperes. So this is my ID. So you can find ID into XT minus XQ. ID into XT minus XQ comes out to be minus 109 minus 109. This will be in volts. So what will be my EF? If you look at this equation, EF is equal to this minus this minus this. Now this minus this we have already calculated to be this one, so it will be magnitude of this one will be equal to 2049 magnitude minus of minus 109. So we'll put plus 109. So that will be equal to 2158 volt. So we will continue with this in the next class once again. Thank you.